Welcome to the CrispMetrics. In this video we will see linear regression with mathematical explanation. This algorithm is used in supervised machine learning. It is widely used algorithm to use regression problems. To use this algorithm we should have independent features and a label variable. It always finds the linear relationship between the continuous or discrete features and labels. It will try to fit best line in the relationship. Formula is, y equals m multiply x plus c, where m is slope, x is feature, c is intercept. Linear relationship between the features. We can check it from scatter plot. Second, the feature should follow the normal distributions. If it does not follow, we have to perform some transformations which helps to convert it into normal distributions. Third is multi-collinearity. The word multi means multiple and collinear means linear, dependent on each other. We have to do this because we know that this algorithm will predict the target based on certain independent variables. So each feature should be independent, it should not depend on other feature. We can detect this from VIF, variation inflation factor, and correlation matrix. Fourth is homosedasticity. This assumption means that the variance around the regression line is the same for all values of the predictor variable, x. The plot shows a violation of this assumption. For the lower values on the x-axis, the points are all very near the regression line. For the higher values on the x-axis, there is much more variability around the regression line. Now the main question is how we can say that the line is drawn is best or not. We can check the residual. Residual is the distance between the actual y and predicted y. For the best fit line the residual should be small. Now we know that the prediction of y is depend on the value of m and c. According to the equation, it means if we got the correct value of m and c, we can say the best fit line is in which we get the lower residual. Here, to get the value of m and c, the concept of gradient descent comes into picture. It is the image of gradient descent. We will see it in our next slides. Now let's take an example and we will try to solve it. We are taking the Kaggle dataset. For example, we are taking height and weight dataset. You will get dataset link in the description. We all know best fit line works on y equals m asterisk x plus c equation. Now we are doing practically. Let's suppose our feature is height and label is weight. Let's move to the blackboard and see the mathematics. If we calculate the above two equation to find m and c values by substitution method, we will get m equals 0.033 and c equals to minus 0.25. Similarly, if we take another two equations from the dataset, we will get different m and c values. Now if we calculate weight by providing the height value from above equation with the help of calculated m and c values, we should get same value, but we are not getting our actual weight. Similarly, left side also. It means we are getting loss because of our m and c values. There are type of loss functions. We are going to use simple one. So you can see 0.16 and 0.01 is our loss values. Our losses should be minimum. So it means with both m and c values we are getting different loss. Now again, question is every equation will use different m and c. So to decide m and c we can use gradient descent. It will try to adjust m and c values to reduce that loss. Automatically fit you best line based on m and c value. Subscribe for more videos.